Hello?
Am I audible? Yeah.
Hello?
Please try to reply. Yeah.
Hello? Your microphone is lagging.
Okay. Okay. Sorry for that. Actually, something. Yeah. Still, it's a problem. Or
No, it's okay.
yeah. Now it's audible, right?
Yeah,
Okay. Okay, Akshay. So your name is Akshay, right?
yeah,
Okay, Akshay. So my name is Pradeep Kumar Yadav. I'm a physics faculty for Indian curriculums like ITZI and NEET entrance examination, and for foreign curriculums like IGCSE, at Excel, Cambridge, AQA, right? I've been teaching since 6 years, right? So today you have selected the topic momentum and forces, right? They
yeah,
told you want to discuss momentum and forces.
yeah,
Okay. So can you see the whiteboard properly?
yeah,
Perfect. Okay, so let's start with the first topic, momentum. Momentum. Okay, Akshay. So if you want to say anything about momentum, then try to explain from your side. If you know anything about this, then after that I will explain. If there will be some mistakes, then I will correct all these things. Okay. So do you know what is momentum? Have you heard about this term before in your school with in the from your
yeah.
friends? Yeah.
Um, like force or motion of an object,
Mm, what? Sorry. It's a kind of push or
push
what?
or pull objects.
Yeah, push and pull is about force, right? Yeah,
Yeah,
momentum is connected to push and pull, but not push and pull the momentum. Let's start this now. So, momentum is about, it's a kind of information, right? It is a quantity. It is a quantity which informs us, which informs us about what? It which informs us about that how hard is to stop something, right? Uh, some moving thing, right? Stop some moving thing. Okay. So if something is very hard to stop, it means definitely it will have more momentum. So momentum is kind of quantity. If you will see that amount or quantity, then you can guess that the object will be hard to stop or it's very easy. So let's talk about the example. If there is a huge bus we have, let's say this is a vehicle, and the mass of the bus is, let's say, 50,000 kg. That's not the normal amount of mass, and it is moving with very small speed, let's say 0.003 meter per second. So I will ask from you, is it hard for you to stop only by applying your hand?
yeah. It's hard,
It's hard or it's easy?
hard.
How can you say that? That's very
Yeah,
moving
but
with
like
very
the its mass is 50,000. No.
yeah. So don't try to stop it with your bare hands, it will crush you. Okay. So is it hard? So yes, is it hard to stop? So you can say yes. But why? Yes, because of its large mass, you can say, right? Or you can simply say, yeah, large mass, right?
Yeah,
It's large mass. Okay. So mass is the factor here that decides that bus is that very slow moving bus is hard or not. So okay. So if mass is a factor, then what about this bullet? If this bullet, it have mass very small, let's say 0.003 kg. You can say that I'm going to take one more zero. It's very light, but its speed is it's near about the speed of sound. You know that sound speed is almost 340-330 meter per second, near about 330 to 340 meter per second. And you know that sound is very quick. As I'm saying something and you are capable to listen immediately, right? 330 is very huge amount, right? 330 meter per second. The speed is very huge, and the bullet is moving near about that. Let's say 290 meter per second. So now mass is very low. So it will be hard for you or it will be easy for you. You can catch that bullet only simply by your hand.
No,
What will happen?
it's
If
too
you will-
fast and it'll just go through you.
Yeah, not go through you only, it will murder you. Okay. So definitely it's very hard, right? Why?
Yeah.
Is-
Because of velocity.
yeah, hard to stop. So you can simply say yes. But its mass is very low.
Yeah, with velocity is the
Yeah.
reason.
So the other information, the other factor that decides the object is harder to stop or not, so that's velocity, right? Yes, because of its velocity, large velocity, right? This time the velocity is larger, and this makes it very large, right? Very hard to stop. So if something have more mass, like train, and that train is moving very faster, so that will be easy or that will be super hard for you.
Which one? Like for bullet?
No, like I'm saying about the train. If the mass is more and the velocity also more, the train kind of example. So train is very heavy, and it's moving also very fast, right?
Yeah,
So what about that?
you
That
can't
will be-
stop it.
So that will be super hard, right?
Yeah,
So both the factors, mass and velocity, both is responsible for the momentum. Actually, momentum is what?
speed.
That quantity which gives this idea, right? So here mass is that quantity and velocity is that quantity. And collectively, if you will talk about mass and velocity, we call this momentum, right?
Mm.
So momentum is represented by the symbol P, right? So basically, for discussion of momentum, basically we were talking about velocity and mass, because these two quantity will give this idea. This huge number of amount quantity that simply gives you the idea that is hard, and this huge number of velocity or this huge number that also gives you the idea, right? So momentum basically talks about this number and this number collectively, right? Because both the quantities are responsible for the information how hard that object to stop. So it's directly proportional to mass. If this will be more, then you can say that is hard. If velocity will be more, then you can say that is hard. So momentum basically talks about both of them simultaneously. It will take the amount of mass, what is the mass is there, what is the velocity is there, right?
Yeah,
And collectively, if any one of the quantity will be more, the total value will be more, right? If you will increase more and more mass, then the multiplication will also increase, right?
yeah.
So the collective information or the collective value of this
M times V.
yeah, m times v. This is the product multiplication. So it talks about if mass will be more, then total mass into velocity will be more, of course, right? So if total value will be more, it means object is harder. If only velocity will be more, again the total product mass into velocity will be more, right? Total product, right?
Yeah,
If you will increase both the values, then again both due to the both increment both of them, the total value will increase. So the collective data of mass and velocity gives this idea, and that we will call that momentum. Okay, understood?
Yeah.
So momentum, this is what momentum, and which kind of this quantity is?
Vector.
Yeah, it is a vector quantity. Why? Because it is talking about velocity, right? Yeah, their mass is scalar, but velocity is vector. So because it is talking about velocity, it means moment. For the complete description of momentum, it needs discussion of magnitude and as well as direction also, because without that, without the information of direction, we cannot talk about velocity. So for the discussion of momentum, we need both the informations, direction and magnitude. That's why it's a vector quantity, right? What is the unit?
M/S meters per second.
What is the unit of mass?
Kgs.
Yeah, momentum. So you can directly see from the formula, you can get the answer. That's what kg meter per second, right? Perfect. Okay, let's talk about some questions on it. Yeah, question is that okay, so momentum of a following object. It is asking for the momentum of a following object. The A part of that, ball of mass 6 kg, right? Traveling at 6 meter per second. So what should be the momentum for that?
6 times 6.
Yeah. How much that?
36.
6 into 6, that will be 36. What is the unit? Tell me.
Kg. Oh, okay.
Kg meter
kg.
per second, right? Okay, so next, ship of mass, you can say 50,000 kg, traveling at 3 kilometers per hour. So then what you will say, what is the momentum?
150,000 kg per meters.
For 50,000 kg. So
Yeah, we
mass,
have to multiply it.
yeah. So mass is how much? 50,000, right?
Yeah.
What about this speed?
3 times 3.
But it is in kilometers per hour, right?
Yeah.
What we need? We need into
meters.
meter per, yeah.
Oh, you can multiply by like 1,000, right?
Yeah, 1,000 divided by the seconds, because here hours means 3,600 seconds, right? So 3 into 1,000, it becomes meter. Kilometer converts into meter.
Yeah.
And then hours would be in seconds. So in 1 hour, how much second is there?
3,600.
3,600.
You really need to like get the 1 hour thingy. You can just make it meters per second.
Yeah, actually, kg, meter, second, Kelvin, all these units are in SI system, right? So you have to take the units in one particular system, right? Kilometer is not the SI unit. Meter is the SI unit. I'm taking here kg, right? So kg is the SI unit. So all the other quantities should also be in SI, right? One times you have to take one form of system, right? If you will take gram in the place of kg, right? Gram. So that is from the CZS system, right? So for that, you should take the length unit will be centimeter and second will be second, right? So be careful about that. If you will take the unit of mass as kg, then Accordingly, all the other quantities should be in the same system of unit. That should be SI. Are you getting my point? Okay, so here you have to take, that's why I'm given here in kilometers per hour, so that you will understand the units system, right? That should be kg meter per second. You can take gram centimeter per second also. So for that, you have to convert kg into gram and kilometer into centimeter, right? You should take all these units into a particular system. Here we are going to take SI system. Okay, what should be the answer for that? Try use your calculator.
Yeah,
It's 50,000 into 3,000. I have multiplied the 1,000 with 3,000 divided by 3,600. So it's 41,666.67 kg meter per second, right? That is what it is.
yeah,
Got it?
yeah.
Next part of this question, C part. A tennis ball of mass 60 gram, right? What is this unit? This unit of mass,
Gram.
but yeah, this unit of mass, this is the unit of mass, but in CZS system, right? So you have to be very careful during the units, because the units should be of same kind of system, right? If you will take unit of CZS, then meter should also convert into centimeter. Otherwise, if you want to take in SI system, then gram should be converted into kg first, right? So I will take in SI, right? So a tennis ball of mass 60 gram.
I have a question.
Yeah.
How to turn the grams into kilograms? Into 1,000?
Yeah, 1,000 gram is equal to 1 kg.
So you have to do 60 into 1,000.
Yeah, of course. So here, a tennis ball of mass 60 gram traveling at 180 kilometer per hour, right? So what should be the momentum? First of all, take the data mass as a 60 gram. So you have to convert that into kg if you want to take in SI system, right? So you have to convert this in kg. Okay, and here the velocity is given how much? 180 kilometer per hour. So what should be in meter per hour? 180 into 1,000 divided by
3,600.
right?
Wait, if it's both kgs, why do you have to make it meters per second? Like if the mass is also kgs and the speed is also km per hour, why do you have to?
No. Actually, SI system, you will study this in year 11, right? Properly. SI system have 7 quantities: mass, time, length, temperature, and blah blah blah. There is 7 quantities. Mass have SI unit kg, so time have second, and length have meters, not the kilometers, right? So here, of course, it's kg, but you cannot take kilometer, because kg is the part of SI, and we have selected meter as the part of SI, not the kilometer. So all the groups should be of same group. All the units should be of same system of group, right? If you will take here gram, then gram is from CZS, not the SI. This is a different name, CZS. Here gram will mass will be in gram, time will be in second, but meter will be in centimeter. That is the part of CZS system. Okay, temperature will be in different. You have to remember that some little quantities. Don't worry about that. Sometimes in your exam, they will write kg, kilometer per hour. But if they will write, then accept that as it is. Otherwise, if nothing is mentioned, then you have to be very careful during selection of the units, right? So you have to use SI units. Generally, try to convert always into SI unit, right? Generally, try to give the answer into SI units. You can use CGS also, but in CGS, this is what centimeters, G is what gram, it's second. SI,
We have a question again.
yeah, tell me.
Mass is 60 grams, no? To make a kg, you have to divide by 1,000. Allah.
Okay, 1 second. Yeah, of course. Sorry for that. 1000 gram is 1 kg, right? So here you have to divide. So here 60 divided by, I forgot that. 60 divided by 1000. This will be what? 1 k, this much amount of kg, right? You can write so simply in this manner. Okay, perfect. So here we have converted values. Use the value for calculation of momentum, right? What should be the momentum then? It's mass times velocity, right?
Yeah.
So mass is how much? 60 divided by 1000. What is velocity? 180 into 1000 divided by 3600. This is what? Kg meter per second, right?
Yeah.
So this 1000 and this 1000 will get cancelled out. This 0 and this 0 will get cancelled by this, right? So 18 into 6. What will be that?
Wait, how do you cancel that? It only cancels the one in the equation. Like
You can use your calculator. This is a one method to manipulate this calculations. We different teachers, we different person use different method. Every 0 you can cancel, right? I use this method for quick calculation. But if you have calculator, then directly use the calculator. Don't worry about this cancelling of these zeros, right?
Okay.
So if they are multiplied or divided, if you have to use by your fingers or just by simple calculation, you have not calculated, then first of all, just cancel all the zeros. How much zeros are there? 1, 2, 3, and 1 or 2 total. How much? 5 zeros are there in denominator, and there is 1, 2, and there is also 5. So all the zeros, 5 zeros will get cancelled out by each other, right?
Yeah.
How much there will be? 6 into 18 divided by 36 only. Otherwise, you can use your calculator. Don't worry about that. In your exam, they will allow you to use calculator. So what should be the answer? 60 into 180 into 1000 divided by 1000 and then again divided by 3600, right?
Yeah.
How much? 3 kg meter per second, right? Got it?
Yeah.
Understood how we have calculated?
Yeah.
Okay. Next, let's talk about one more question, then we will talk about the forces. Okay. Let me use a small question. Okay. A rocket of mass how much? 1200 kg is traveling at 2000 meter per second, right?
Yeah.
And it fires its engine for 1 minute. Okay. Okay. The forward thrust. Okay, just try to calculate momentum because you haven't studied the force.
1,200 times 2,000.
So
It's
1200,
200.
1200 kg is the mass and 2000 is the speed, right?
It's 2.4 million.
Yep. So here you can say 12 into 2, it's 24. These 2 zeros and there will be 3 zeros. This much amount of kg meter per second, right?
Yeah.
Okay. So let's talk about forces. Okay. So do you know anything? What do you mean by the force?
Push or pull.
Push or pull?
Yeah.
Okay, let's talk about the term. Why we call push or pull as the force? Actually, we have heard about this term force or forceful activity, or force him. Hey, don't force me. You have heard this word lots of time in this manner, right?
Yeah.
So what do you mean by this? What
Like, don't do it.
don't force me. Don't force me to do that thing. Actually, whenever you want something from someone, right? That someone should do this kinds of thing according to you, but that person or that thing is not doing according to you, like your dog, your pet, right? So
Yeah.
what you will do then?
Force it.
Yeah, you will force them, right,
Yeah.
to perform their activity according to your desire, right? So in the same manner, in physics, basically we talk about non-living things. We talk about non-living things, and non-living things, they have only capability to be at rest, or they can move here and there, or they can collide with some other things, right?
Yeah.
So they can only be at rest, or they can only move here and there. But if if some object is just at rest, and you want that thing should move from some place to other place. So what you have to do, because that object doesn't have the capability to move by itself, okay, from that location to that location, but you want the movement in that object. So what you will do then? That is not performing that activity by their own. So in this case, you have to force that activity. Are you getting my point? Why I'm
Yeah.
saying force? But for forcing that non-living thing, you cannot shout over that person, that thing, right? Because that cannot hear you, that cannot see you, that cannot see your anger, right? Everything. That can only be at rest, and that can move from here and there. This is only thing that can perform. So for movement, what you have to do? You have to force, and for forcing, first of all, you have to go into contact with that. And if you will go into contact, what will happen? That object will start movement, right? That object get forced to move, to change their location. Are you getting my point? So
Yeah.
for forcing that object, what you have done?
Push it.
Yeah, you have you come into contact with that, and you are pushing and pulling that. So that activity, pushing and pulling, becomes a kind of force, right? You are forcing that non-living thing with the help of pushing or pulling. Are you getting my point?
Yeah.
That's why this activity is known as force, the push and pull, right? Forces are a push or pull of one body on another. Are you getting my point?
Yeah.
Here are a number of forces. Types of forces. You can say types of forceful activity, right? So one of the type is what? Contact force. Some forces are non-contact also. They are very mystical, right? That magical actually. We don't know how that non-contact force are acting, right? It's magical because if I will just wave my hand and you will start flying in the air and it will be very you can understand, right?
Yeah.
So there are magnetic, gravitational, and electrostatic. These three forces are there as a non-contact force, but they are very mystical and magical, right? We don't know exactly how they are coming into picture, right? So just we have seen that magical activity performed by the matter, right? So when two surfaces interact, right? So there will be contact force. Next, gravitational. If you will leave something, that will fall. And not only fall, the speed will increase continuously. It means that is accelerating, right? The movement is changing. And the objects cannot change their movement by their own. Speed increases. The object cannot increase their speed by their own, right? There need to be some force. Who is applying? There is nothing around it. Just its speed increases, right? That fascinates the scientists everywhere, right? That's very um, interesting. Like if you will see a chair on their one leg, so that will be very interesting to see how that is just on one leg, right? That's not usual thing. Okay, are you getting my point?
Yeah.
So and you are getting fascinated if you will get fascinated, right? If you will see a chair on the one leg, this not happen generally. In the same manner, scientists just get fascinated by falling objects. Not only falling, that object is accelerating. They are also get shocked. Why the speed is changing? As you have solved for one chair, one the chair on the one leg, right? Same kind of feeling they faces during the falling of object because they haven't seen anything to force. So they after years of study they understand there is earth actually pulling that object mystically, right? So gravitational force. Next is what? Magnetic and electrostatic. These three forces are non-contact forces. Electrostatic, static. Are you getting my point? So there
Yeah.
are another names of forces also. They are mostly non-contact and contact. So one of them is elastic. This is a electromagnetic or electrostatic force. Upthrust. You will hear these words in coming chapters, right? Upthrust is what? The upward push, upward push of water, upward push of water on static objects. Static objects like a bottle, right? What is going on? Bottle is not sinking. Why? Because water is applying some upthrust on the bottle. Are you getting my point?
Yeah.
Next, drag. This is the another usual force, practical force. You will see like when you will be on bike, then you can experience the drag of air. Are you getting my point? So drag is basically a form of fluid friction. Fluid is what? Liquid, gas, right? A form of fluid. friction, right?
Yeah.
Friction means resistance, right? Resistive force, right? Which are that forces which resist your motion, right? They are not uh, they are not letting you go easily, right? So drag, okay. So these kinds of forces we have. Next thing is what? The force is a vector quantity, okay? Forces are vectors. Okay, if you want to understand why the forces are vectors, let me give you an example. Let's say there is a 4 Newton. Vector quantities are those quantities which require two informations for their complete description. Two informations like magnitude and their direction also, right? Uh, as if there will be two boy name is Akshay, so only Akshay is not right. The only Akshay information is not sufficient because there is two Akshay, right? There are two Akshay. So
Yeah.
one more information like your title, your color, your age, these kinds of features will help you to identify, right? In the same manner, forces require magnitude and direction. Let me explain this. Here, what is going on? A 4 Newton force is acting on the block. And I'm just trying to explain what is going on in front of me to my friend, which is on the other side of phone, right? That is not present here. I'm just explaining that, hey, bro, what is going on? There is a 4 Newton force acting on a block, 4 Newton force acting on a block. Just I'm saying 4 Newton. I haven't given any information of direction. So tell me, he will get properly what I'm
No,
watching? What is the problem? He
I'm
can
not telling
assume
him where it is.
he can assume this 4 Newton also. This is also the 4 Newton, and this 4 Newton and this 4 Newton. These two forces are different exactly. This 4 Newton is trying to push it in forward direction. It is trying to move it, accelerate it. And this force is trying to crush it. Are you getting my point?
Yeah.
Both the forces are different thing. So I'm just observing this 4 Newton, but he was feeling that something is getting crushed. Are you getting my point? So I have to say one more thing about that force, that is for direction. That direction is the unique information for both of them. Are you getting my point? There are more than one kind of 4 Newtons. There is the necessity of one more information for their complete description. Are you getting my point? That's why forces are vector quantities. So here you can say vectors have size as well as direction, right? Let's talk about the resultant force. What is resultant force?
Total force.
Yep, total force. Perfect. Resultant force. So it is what? A resultant force can be calculated by adding all the forces acting in one direction, right? Adding in one direction. First of all, this is the case one. When all the forces are in one direction, then you can add all of them directly. You will get a resultant force. This is the one case, right? So here, let me say there is a car. In this manner, the car is experiencing there 120 Newton, and someone is pushing it also, right? Let's say 20 Newton, right? So what is the resultant, or you can say
100 newtons to the right or the left.
will be that 120 plus 20. It's
Oh yeah, you have to. Oh okay.
because the directions are same. Can you see that?
Yeah.
That's why. But in next case, if the forces are in opposite direction, then what you can say?
You can minus it.
Yeah, then the resultant force will be the subtraction, right?
Yeah.
Resultant force will be the subtraction of those forces, subtraction of those opposite forces, right? Are you getting my point?
Yeah.
Forces. Okay. So here, if 120 is due to the drag, sorry, here let's say 40 Newton is due to the drag on the car. Okay, and the car is moving by an engine force, let's say it's a 140 Newton in forward direction. So what should be the resultant F net?
100 newtons.
140 minus 40, it will be
100.
100 Newton. But what should be the direction of the net force?
Left.
In the direction of larger force, right?
Oh, so it's right for
In the direction of larger force,
right.
right? So 100 Newton will be there, okay? But in the direction of larger force. Be careful, right? The resultant force direction in the direction of larger one during subtraction, right? During subtraction. Are you getting my point?
Yeah.
What about if the car will experience force here in forward direction? It's 30 Newton, and one more force is there. Someone is pushing by 20 Newton, but there is a drag force, but is in opposite direction. Drag force is 50 Newton. What should be the total resultant force? Can you say that?
Wait. 10, no? 10 newtons?
Okay, there is 30, this one, and this 20. They will get added directly, right?
You said 15 newtons there.
50.
So it'd be 15 newtons, right.
Yep. No, it's left. This is towards left, right?
But the arrows are going right.
Yeah. The car is not going anywhere. Actually, the force is 30 Newton. Force is 20 Newton in the right side. and 50 Newton is the drag force in the left side, right? How much forces are there? 3 forces, right?
Yeah.
2 forces are in right. This is what, right side? Okay. And 1 force is in left side. Are you getting my point?
Yeah.
So here 30 plus 20, because these 2 forces are in same direction. Are you getting this?
Yeah.
So they will get added directly, and minus times of 50 you can add in this, subtract that. So 50 minus 50, how much the net force?
0.
Yeah, car will not experience any resultant force. Got it?
Yeah.
Okay. So this we have complete discussion. There is another discussion, so also the relation of force with the mass and acceleration. And after the discussion of the relation with mass and acceleration, we will talk about the relation of force with the momentum, that is change in momentum divided by change in time. So there is lots of things to discuss in it, okay?
Okay.
But we don't have that much time to discuss all these things, okay? So tell me, how was this lecture? Everything is perfect, perfectly understandable, or there
Yeah.
is something
It's
something
nice.
that you're losing in this discussion? Then you can share with me. I can explain that again. Okay. Okay. So your name is Akshay, right?
Yeah.
You are in year 10, right? Year
Yeah.
10, and you are preparing. You are taking classes in AQA.
Wait.
Sorry, it's Cambridge or Edexcel? IGCSE.
Wait, do AQA.
AQA. Okay.
IGCSE
Oops.
AQA.
Okay, no problem. Um, which the school teachers, they have given you some book?
Yeah. Textbook.
Okay, so every student have different syllabus, right? They every school, they have different syllabus. I have lots of books for that, but you should what you have to do, if you will continue further, then you have to just share the book link of the PDF of book that will be available definitely on the internet. You have to share with the management, they will share with me then. Okay, then I will follow proper the syllabus if you want to continue. Are you getting my point?
Yeah.
Okay, perfect. Nice to talk with you, Akshay. Is there anyone else?
What?
Is there anyone else sitting with you?
Yeah.
The parents, I think.
Yeah.
Yeah. Okay. Uh, hello, sir. Am I audible? Is there anyone else?
Hello?
Okay, no problem. Yeah. Hello, ma'am.
Yeah, hi.
Yeah, ma'am. So how was this class?
Akshay,
Uh,
how was the class? Okay, he says good.
okay, no problem. So you can discuss with yourself and the student also.
So you will be the tutor for physics? Like if we decide? Okay.
Yeah, of course. If you
Uh-huh.
will decide, then you want to move with me, then they will arrange they will organize the
Achha.
schedule also, all these things, right?
And the class is 1 hour or how much? 1 hour.
It depends on you also. If you will say that you need more time because you have to cover more syllabus in short interval of time, then you can say to the management, they will inform me, and I will
Okay.
tell my time, and I will be available,
So
and we can.
you teach in school or something?
Actually, I'm in India.
Okay.
I'm an entrance faculty. I have been teaching since 2017, so I have nearly 6 years of teaching experience, and I, as well as I'm teaching IGCSE schools, right,
Mhm.
for online. And I was
Okay.
planning actually. I'm planning actually to go Dubai and some other. Actually, I'm preparing with Surasa for getting a teaching certificate properly, because I'm a BTech graduate from mechanical branch,
Okay.
right?
Mm-hmm. Okay.
So the schools are demanding that you should do some B.Ed degree, because I don't have time that much. So I have joined Surasa, that provides the degree, actually, degrees, teaching certificate, that is Britain based, actually, right? That is present in UAE also.
Mm-hmm. Okay.
Almost 1 year. After 1 year, they will give me proper certifications, and then I can relocate it to Dubai or anywhere else. Right.
Mm,
So I
okay.
have been teaching for ICCSE or Cambridge or AQA since, you can say, I have experience of 2.5 years. You can say 2.5
Mhm.
years.
Okay. Yeah. Okay.
Okay, ma'am.
Okay. Fine. Yeah.
Okay.
Thank you.
Thank you so much. So let's end this
Thank you.
lecture here. We'll meet again.
Yeah.